Start. Okay, so we have 5 types, right? Type 1 to 5. Okay, uh, at EVPN type route. So type 1 and 4 is for multi-home devices, right? We already have discussed type 1. Today we will discuss type 4. Okay, type 2 is for host route advertisement. So that is for Mac advertisement and ARP advertisement, right? So Mac and Mac plus IP, that is ARP advertisement. Type 3 is inclusive multicast route, which is for advertisement of IMET routes, basically flood list, right? So that is to advertise the flood list. And type 5 is for L3 EVPN, so to advertise IP prefixes. Okay, so these are the different types. Okay, let's go one by one. Before we go back to type 1, type 4, let's go back and discuss. So this is the common format, right? So this is the common, format where you have MP reachability and LRI, right? And then flags, and then AFI and SAFI, right? And after that, route type. Which route type you want to advertise? You want to advertise type 2, type 3, type 4, right? Length of that route, and then header related to that route type, right? Type 1 to 4, 5. Okay, so this is how it is. It will basically packet header will be, right? Type add route type. And these are different variants of multi-homing, right? It can be active standby, it can be active, and it can be multi-home active. So you can also have 3 different devices. Basically, your switch, your server can be connected to 3 different devices, right? And all these are not in MLAC. These are not in MLAC, right? So that is how it can be connected, right? Now let's go with first type 1 Ethernet auto discovery route, right? So this is used for multi-homing. Okay, so when you don't have basically this MLAC peer between these 2 devices. So whatever MAC you learn here, right? That somehow, how will you know that this Ethernet segment is common, right? Between these 2 devices, correct? So that's why we need to use type 1 and type 4 route, right? We will see what are the purpose each one of this solves, right? But basically for multi-homing devices where you don't have MLAC pair between 2 devices, we use type 1 and 4. Okay. So mostly you will not see this is used in DC or VXLAN, right? In VXLAN environment, you will see very rarely, but obviously in service provider environment, right, with MPLS, you might see a lot or maximum usage of this. Okay, so type 1, there are 2 main, basically there are 2 functionality or use for 2 reason, right? One is fast convergence. So basically we will discuss basically what is this fast convergence, and another is aliasing, load balancing across multiple egress points, right? So let's discuss what is this both are, right? How we achieve this. Guys, feel free to stop me, right? If you have any question around this, I might be going fast as it is refresh. It's just, okay. So what basically this is the configuration, what you will do, we will do for multi-homing, okay, on both the devices. So basically this customer A is connected to both the PE devices, PE1 and PE2, right? It's a multi-home and you don't have MLAC peer between PE1 and PE2. You can consider this as VTEP 1 and 2. You don't have MLAC link, right? Link. So your general configuration is this much, right? That is port channel 110, switch port access VLAN 1000. But to configure multi-homing when you don't have MLAC peer, right? This is the extra configuration you have to do on port channel, on this port channel, right? This port channel on both the devices, both sides. Okay. So first of all, let's say we want to bring this port channel up, right, on customer A side, right? And this is LACP. What is the first challenge, right? What is the first challenge? System ID, right? So basically P1 will send the different system ID, P2 will send different system ID, and this port channel will not come up with both the members, right? So basically, first of all, we have to make sure we are using same system ID, LACP system ID, right? So on both devices on this port channel, we will configure same system ID so that both sends this packet on this port channel with the system ID and this port channel comes up. So that is the first requirement, right? Another is how you will know that these two are connected, right? Both are sharing the same Ethernet segment. This is one Ethernet segment, right? So how P1 and P2 will know that we both are sharing same Ethernet segment? So that's why you need to configure this Ethernet segment identifier, right? So this is the identifier you will configure same on both the port channels. Okay, it should be same. And for any other device, let's say this customer B is connected to both the P1 and P2, whatever Ethernet segment ID you configure here, that should be different, unique. It should not be same like this. Okay. So for each devices in the network which are multi-home, for that connection to that multi-home device, that port channel should have unique Ethernet segment identifier, right? And there are different ways of Ethernet segment identifier. Generally, what we use is starting with 00. So we will use always starting with 00 and followed by anything. Anything can be, we can use anything, right? So that is called Ethernet segment identifier. We'll see the significance of Ethernet segment identifier going forward, right? And another thing we use is route target import. Okay. So this, we already use route target, import and export under BGP, right? Under router BGP, under MACWOF, right? Under VLAN, let's say VLAN 10, right? We use RD and RT, correct? But that RD and RT is not, this RT is not same as this RT. This RT is different, okay? And we will also see why, what is the purpose of this RD. But we will use this route target import, right? Different on this configuration on the, under this port channel. Okay. So basically this is the configuration we will use, okay, to configure this port channel. Basically, yeah, to bring this up multi-home device. Okay. Any question? Okay. Yep. So these are the few points, right? You need to configure multi-home site. So locally configured AES must be provided an RT, right? That enables P is connected. So basically you should configure route target, right? P is connected to the same Ethernet segment must have identical MACWOF configured. So we discuss about, configuration of under router BGP VLAN 10, right? So that MACWOF configuration also should be identical on both of this P1 and P2. Okay. All PE devices are, all PE is connected to the same C, also has same Ethernet segment must be configured, right? Same LACP system ID. So this should be same on both this, right? So, and EVPN, the last one, right? That we will see later, that designated forwarder. So that is used in type 4 that we'll discuss. Okay, now let's discuss about aliasing feature, right? So type 1 gives us is used for two things, right? One is aliasing and another is fast convergence. So let's talk about aliasing feature. So basically what we do is, let's say this server is communicating to any other server or trying to communicate to any other. As soon as it sends the packet, it will send packet on either of these two link, right? This is port channel, so it will send packet either on this one link. So let's say it has sent packet to PE1. You learn the MAC address locally here, right? You learn the MAC address, that MAC address of server 1, and what you will do is you will generate type 2 route, right? Type 2 route. So this is the type 2 route you have generated, right? Which has MAC information and MAC plus IP ARP information, and you will advertise this to PE3. So now PE3 will know that, hey, to read the server 1, right, MAC of 1, I have to send packet to VTAP 1, right, VTAP 1. This is by combination of MAC address table and VXLAN address table. So it knows that, hey, to send the packet to MAC 1, I have to send packet to VTAP 1, okay, or PE1. Now, as soon as you configure the above configuration related to port channel, right, on both of these devices, they generate type 1 route, okay. And in type 1 route, they advertise the Ethernet segment identifier. Even you, if you remember, Ethernet segment identifier is also there in type 2, but in type 1 also you send the Ethernet segment identifier, right? And basically you say that, hey, I am associated, this PE1 is associated with this particular Ethernet segment A, okay, A. So I have common Ethernet segment A, okay, and that is sent to this guy. Similarly, P2 also will create type 1 route and say that, hey, I am also associated with Ethernet segment A, and it will send this route, type 1 route. Now combining, so basically what it says is that Ethernet segment, right, Ethernet segment identifier A is common, is available on both VTAP 1 and 2, right, and 2, both. So if you combine both of this information, right, what you will understand is that, and you also know that this MAC 1 is part of Ethernet segment A, right? That MAC you have learned is also associated with Ethernet segment A. That also you know. So if you combine both of these, this PE3 will understand that, hey, to reach 1, right, which is part of Ethernet segment A, and as per other information I got, that Ethernet segment A is shared by both the VTAPs, right? Both the VTAPs. What does that mean is that if I want to send the packet to 1, I can send that packet to either VTAP 1 or 2, right? Both. So basically, it will install this as a ECMP path that I can send packet to any of this. I have path, right, to send packet to PE1 or PE2. Okay. So that's how this is called aliasing. So basically, remote VTAP will understand that, because in MLAG, we basically the VTAP IP for both is same, right? 1111, 1111. And that's why you know that, hey, this is to send packet, I can send it to VTAP 1111, and spine will advertise either of this, right? Based on ECMP. But now in this case, VTAP IP is different. One is 1111, other is 2222, right? So you need to have route for both of this. Basically, you need to have MAC reachability for both of this. And that's how you will, by using this type 1, you will install that route. Okay. Any question? Okay. So if I have to show you here, right? So, 1 minute, let's ping. So if you see here, right, this particular MAC address has 2 VTAPs, right? So that shows that, to reach this particular MAC, you have 2 VTAPs, 2 different VTAPs, right? So, okay. So yeah, that's how this aliasing feature works, right? So even though you don't have AMLAC pair, the other VTAP will know that you can reach this particular subnet by 2 VTAPs. One more thing I want to bring to you is, see, for single home device, right? For single home device which is connected only to PE1, you don't have to configure all this, right? This is required only when you have dual home device, right? Multi-home device connected to multiple devices. Okay, so just to keep in mind. So this is aliasing. Now there is another feature which is mass withdrawal feature, right? So basically, let's say generally what happens, let's say this Mac has learned, okay, so this is a switch, okay, so this is the switch connected multi-home to both the VTAPs, and behind switch there are 100 hosts, 1 to 100 max, okay, hosts. Now what you will do is, as soon as you, let's say all the Macs are sending traffic through this VTAP initially, right? So you learn all the Macs here, right? You learn all the Macs here. You advertise type 2 route to all the VTAPs, right? So VTAP 3 will know that to reach all the max 1 to 100, you have to send packet to which VTAP? VTAP 1. Okay. Now, as we discussed, you will also advertise type 1 route, right? Type 1 route from both the VTAPs. Aliasing feature, right? So because of that, now you know that, hey, to reach all, and all are connected to same Ethernet segment, right? Both the VTAP is connected to same Ethernet segment. This Ethernet segment A is common. So based on that, this VTAP 3 will know that, hey, to reach all this max 1 to 100, I can send packet to either VTAP 1 or 2, right? Because of this aliasing plus type 2 route, type 1 and 2 route. Now, let's say this link goes down. Okay, what will happen? This link goes down. Now you have to send 100 withdrawn routes, right? 100 withdrawn routes for this guy to VTAP 3, so that you remove VTAP 1 from the table, right? But what will happen if you remove type V2 route? Then this route also will go, because the only source of type 2 route was VTAP 1, right? So instead of doing that, what we do is, as soon as this link goes down, right, what will happen? Traffic will start flowing through this VTAP 2. So VTAP 2 will learn this MAC locally, right? Locally, all this MAC will be learned on VTAP 2. As soon as it learns the locally VTAP 2 MAC, it advertises type 2 routes, right? It advertises type 2 routes. And now after this has advertised type 2 route, if you withdraw that route, 100 route, then also it's not a problem, because now type 2 route is already there. What one more thing what we do is, we send out type 1 route withdrawal, right? One type 1 route withdrawal instead of sending, withdrawal route for all these 100. So what that will do is, that will tell that, hey, VTAP 1 will tell that, hey, now I am not connected to Ethernet segment A. Okay, I am no longer connected to Ethernet segment A. So you remove for all these 1 to 100, right? You remove E1, VTAP 1 reachability. Okay, now you have only VTAP 2 for all this, because the type 1 withdrawal route will be sent by this VTAP 1. And that's how basically you will have now left with all the MAC addresses only through VTAP 2. Okay, so that's how type 1 withdrawal route feature works, that it will, instead of sending individual type 2 route of withdrawn, it just sends out type 1 route for Ethernet segment, so that, hey, I am no longer connected with this Ethernet segment. So you remove that. Okay, and it will also delay the MAC address withdrawal type 2 route, because for some time, so that meanwhile this VTAP 2 will send out type 2 withdrawal, so that this MAC address does not flush out, okay, on the remote VTAP. So this is how mass withdrawal works. Okay, any question?
Hey, Vishal.
Yeah.
So we just wanted to ask about the timer thing. So how long will it wait to identify that the Ethernet segment is down? And
Okay.
yep, all those stuff.
Yeah. So see, basically, I don't know exactly, but it will be pre-coded into this in our design or implementation. So exactly, I don't know what will be the timer, right? For how much time it will wait before it sends out some MAC withdrawal, right? MAC type 2 route. but it will be delayed so that at least type P2 will learn all traffic will start flowing from here and it will start type 2 routes, right? And then only, so maybe it might be in some microseconds or some seconds, but yeah, exactly, I don't know. But yeah, that one thing is sure, that it will not immediately send type 2 withdrawn route. It will send type 1 withdraw route, but type 2 it will wait for some time.
Okay, thank you.
Okay. So next is, yeah, type 4 we will discuss, but yeah, before that, let's quickly go through the type 2 route, right? So type 2 route, basically we advertise MAC address information and ARP information, right? And this is the header format for that, right? So information will be route distinguisher. This is common header, right? Okay, sorry, not this, the this one is common header, which is for all the Ethernet type route. And then this for type 2, it is route distinguisher. Ethernet segment identifier is 0 in case of MLAG, right? But if it is not MLAG multi-home, then it will be the configured one, which we have seen before. Ethernet tag ID also will be 0 for VLAN based, right? But for VLAN aware, it will have some value, a VLAN value. MAC address length and MAC address, so it will send out the MAC address, which is learned. And in case of MAC plus IP, it will also send out IP address and VLAN VNI label, right? Basically, this is nothing but VNI. Then extended community route target, routers MAC extended community, right? And then extended MAC mobility. This we will see later. Okay, just this is optional. Extended community MAC mobility, that is related to MAC mobility, right? In case of MAC move. And tunnel encapsulation will be VXLAN in this case. In case of MPLS, it will be MPLS. So this is the packet format, right? So basically what will happen is, as soon as you server one communicates with anyone, right, or to the gateway, the MAC or ARP will be learned locally. As soon as this MAC and ARP is learned, it will generate type 2 route, which has one information is only MAC address and another is MAC plus IP. So it will send out two update messages, right? The sequence number, when this is the first time, sequence number will not be there. It's optional, right? It will just send out MAC and ARP information separately. This VTAP2 will learn this MAC and ARP, right? Type 2 route, basically it will learn, get the type 2 route, and it will install it into the MAC and ARP table. Okay, MAC and ARP table. Okay. So this is how, and similarly for server 2, as soon as it learns the locally, it will advertise type 2 route, MAC and MAC plus IP, and that will be received. Type 2 route will be received here, and it will be installed, update its MAC and ARP table. So this is how basically, MAC and ARP type 2 works, right? And this is the packet capture format, right? So this is the MAC type 2 route, right? Before that is AFI and SAFI, which is common. And then type 2 route distinguisher, RD value, what you have configured under router BGP. ESI is 0 because this is MLAG, right? Ethernet tag is also 0, it's VLAN base. This is the MAC information, right? What we are going to send. MAC, what is learned locally, and we'll advertise it. And then this is MPLS label or VNI. So initially on older PCAP Wireshark, it was showing some bogus value, but now you can see the actual value of VNI. And then you will have followed by route target, RT value, right? And then VXLAN encapsulation type, VXLAN. Okay. So this is the format of type 2 route, and that will be advertised. Not sure why it got stuck. Okay. Just a minute. It's asking for sign in. Sorry, just give me a minute. It's asking to sign. Meanwhile, any question anyone has so far?
I think it's good. Thanks, Michelle.
Okay. 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 Let me share my screen again. I hope are you able to see my screen?
Yes, yeah.
Hey, Vishal,
Perfect.
one
Yeah.
question. So, in referring to the mass withdrawal feature. So, if the if the P which is not part, which is now not part of the Ethernet segment, if it when
Mm-hmm.
it sends when it sends the type 1 withdrawal, right? And by the time P2 has not learned the has not learned the C's MAC directly.
Mm-hmm.
So when so would the MAC on P2 get flushed?
Okay. So let's say okay. So see, generally it should be immediate. Okay. So as soon as your link, this link goes down, right? What you will do is you will send out type 1 uh, basically mass withdrawal, right? Now, as soon as, see, if you have continuous traffic, as soon as this link goes down, immediately it should fall back on this P2, right?
Yeah.
So it should have learned immediately, right? And then as soon as it learns, it will send out the type 2 route to other PE devices. And based on this withdrawal route, it will remove this PE1 from its table. That now ESIA is only reachable through PE2. Okay. So generally that should not be the case, right? But if in case, if this Mac, any of this, let's say one device which is behind this has stopped sending traffic even. So in that case, there is possible that type 1 route withdrawal route is sent here, it's going to receive here. And in that case, this I need to check what happens on PE2, right? Whether it removes that MAC entry from here or not. But in any case, still P3 will have P2 reachable for that MAC, right? So basically it is still there because type 2 MAC withdrawn route is not sent, right? So P3 will still send packet to P2. And in case P2 has removed that MAC tab entry, right, which is common because it has not yet learned locally, it has just learned through P1, right, through Ethernet segment. So in that case, it will flood, right, if it has flushed out that MAC entry. But traffic should still flow.
Yeah, that makes sense.
Okay. But yeah, we can check that. We need to check on NLab exactly whether this P2 is removing or not, right?
Yeah.
Based on that type 1 withdrawal.
It should remove it, right? Else there would be
Yeah,
max
yeah.
volatility and
Basically, yeah,
max
it should
modes.
remove. It should remove. Then only it will learn it locally, right? Immediately. Okay. So now let's go to type 2, right? This present. Okay. Yeah. So basically, as we discussed, we will send out two different type of routes, right? For MAC and IP separately, because in switch also we have MAC aging timer and ARP aging timer is different. So it's possible that at one particular time only MAC is expired age out, but ARP is still there. So that's why we have to send two different updates in separately for MAC and ARP. Okay. And then this is the Mac mobility, right? So, we let's say first this Mac is learned here on this VTAP1 locally. As soon as it is learned, it will send out type 2 a route update. During the first sequence number is 0. So basically there will be nothing mentioned in the packet. Okay. About sequence number. Now type 2 VTAP2 will learn and update its Mac table. Okay. Now what happens is, let's say we move that host from VTAP1 to 2, right? So now what will happen is, this guy will learn the Mac locally. As soon as it learns the Mac, right, it knows that I have already learned that Mac through VX1, right, from other VTAP. So now to send the updated message, because there is VTAP3 also who has initially learned that Mac through VTAP1, right, VTAP1. Now this guy has learned it locally. It will send out type 2 route, generate the type 2 route, but with incremented sequence number. So now it will send with the sequence number 1, right, which will go to this guy as well as this guy, right? And both will update now that, hey, now to reach Mac 1, it's a VTAP 2, right? VTAP 2, not VTAP 1. Because I have whatever information I have received, it is updated one. Sequence number is updated one, right? So this is how Mac mobility works, okay, in type 2. I'm not going into detail because we have discussed this in depth before, okay. Third is IMET route, type 3 route, right? So IMET route is nothing but to advertise the flood list information, right? So local VTAP information. So basically this is the packet, extra form, extra fields, right? So you will advertise route distinguisher, Ethernet tag, right? Again, it will be 0 for VLAN base and VLAN aware. There will be some field, IP address and router IP address, where my VTAP IP address, right? The VTAP which is advertising type 3 route. And this is length. Extended route target, tunnel encapsulation VXLAN, and PMSI tunnel attribute, whether we are going to use multicast replication or ingress replication, right? We have two types of multicast, which we don't use, but another is ingress, means HER, hidden replication, right? So we will use ingress replication, hidden replication, right? So we are going to use this in our update message, okay. So basically, yeah, we will send out as soon as you configure that VXLAN and route VLAN based configuration MacWaf under router BGP, and as soon as you configure a configuration that under VXLAN VLAN 10 VNI 100, right? So as soon as you configure this information, the VTAP will generate type 3 route, right? Type 3 route, and send that, hey, I am part of this VLAN 10 and the VNI is 100. Okay. So basically it's saying that, hey, if there is any bump traffic, right, for any of this VLAN 10, you have to send it to me as well. I am also part of this. This VLAN is extended to me as well. Okay. I have host behind behind this VTAP. So basically what you are saying is, hey, I am VTAP 1111 and I am part of VLAN 10 and VNI 100. Okay. So when this information reaches to another VTAP, it will update its flood list table, right? VXLAN flood list table. So we'll see this in next slide. Right. So these are VTAP 1. So it's saying that, hey, I am VTAP 1. I have VLAN 100 and also I have VLAN 200. Both VTAPs are here. So by receiving this, what it will do is, right, all the VTAP will learn this, that, hey, for VLAN 100, VTAP 1 and 2, because both will send this information. Okay. So VTAP 1 has VLAN for VLAN 100, you have to send packet to VTEP 1 and 2, right? For VLAN 200 also, we have to send packet to VTEP 1 and 2 because everyone has sent that, hey, I have VLAN 100 and 200 available. And based on that information, they will populate the flood list table. This is called type 3 EVPN route. Okay. Any question? Okay, so now let's move to type 4. Okay. Type 1 we have already seen, right? What is the purpose of type 1? So that is aliasing and mass withdrawal, right? So type 1 and 4 are for multi-home devices where you don't have MLAC pair, and you will use this type combination of type 1 and 4. So type 1 is for aliasing, that is load balancing, right? VTEP 3 will know that I can load balance traffic for VTEP 2, VTEP 1 and 2. And another is mass withdrawal, right? So this is type 1 and 2, correct? Type 4 is dynamic discovery of multi-home VTAP peers, okay? And then another is designated forward election. So let's discuss both of this, okay? Let's say this is multi-home device, this switch or the host is connected to 3 VTAPs, okay? Now, let's say it is sending some packet. It has to send some packet to any other VTAP here, any host here, right? Behind this VTAP, VTAP 4. Now it will choose either of this one link, right? So it will send traffic to any of this one link. Okay. This will learn the MAC address locally. So this is, let's say, MAC A. So it will learn that MAC A on this particular port channel, right? Port channel 10. But this other VTAP does not know, right, that this MAC A belongs to locally. They have to learn. In case of MLAC, what will happen is MLAC will sync that MAC address to MLAC peer, right? And they will learn that, hey, MAC A is behind my port channel as well, right? But in this guy does not know that there is MAC A behind me, right? This link. So how that information will be sent is by using type 4 route. Okay, type 4 route. Dynamic discovery of multi-home. Basically, how this other VTEP will know that, hey, we are sharing the common Ethernet segment, right? Whatever MAC address I have learned on this Ethernet segment A, the other guy is also sharing, and I can use the same. Basically, I can learn that. So this guy will send type 2 route, which all the other guy will receive, but it will also advertise information, right? Which will tell this guy that, hey, we are common Ethernet segment, sharing common Ethernet segment. We are peers. Okay. So how that is achieved, we'll just check in next slide. But just first, let's check what are the fields information is sent, right? So it will send route distinguisher, RD value, right? Ethernet segment identifier, the ESI value, what you have configured under port channel, router length, IP address length, and IP address address of this VTAP IP, right? 1111, let's say. Extended community tunnel encapsulation, whether it's a VXLAN encapsulation or not, and import route target, Ethernet segment import route target. So this is the configuration under port channel. So that is this configuration. So this route target information which this guy is going to send, that is from this configuration. Let me show you under port channel. Okay. This one. This route target. Okay. Not the other route. RDRT is also there under router BGP, right? Under router BGP, under VLAN 10, VLAN base, you have RD and RT, right? You configure RD and RT, right? So let's say 200:200 RT, import export both. Not this RT, but this route target is what is sent in type 4 route update message. Okay, under port channel 10. And this is unique for each port channel. So if there is another port channel here, right, this route target under port channel 10 or 20 right? Port channel 20 will be different route target compared to this. Okay, it can be 0105. Okay. However, under VLAN base, yeah, that is different, right? So you are going to send this route target, okay, under port channel. Now what will happen, right? So this is the update type 4. Oh, 1 minute. Okay. So now what will happen? 1 minute. I don't know why. Okay. So now let's say this guy has sent some packet on this interface. Okay. It has learned the MAC, and also you have configured, port channel configuration, route target, and all that stuff. As soon as you have configured this route target and all that stuff, this P1 will advertise type 4 route. Okay. What are the information it will have is that Ethernet segment identifier. I am connected to this Ethernet segment identifier, right? My IP address is 1111, right? I am VTAP 1111, right? To understand the other VTAP, that which VTAP has sent this information, and I am associated with route target RTA dash. Route target what you have configured under port channel, which was 0104, right? Under port channel 10. Okay. So this information will be sent to all the VTAP. So it will be sent to this VTAP, which is 2222, to other VTAPs 3333 and 4444. Now what will happen? This information is received by this guy, right? Now what configuration you have made here? You have under port channel 10, you have configured this, right? Route target, same route target 0104, or in this case RT dash A, RT A dash import, right? You have configured this, that import this route target. So basically what it will do is when you receive this route target RTA dash, okay, RTA dash, when you receive this, you will import this into the route, into your table. And based on that, you understand that. And then when you check inside, you check that, hey, Ethernet segment A is part of this VTAP A 1111, and that is also part of me, right? So you will understand that, hey, this is my neighbor. VTAP 111 is my neighbor, right? Same as MLAC pair. So you will now know that VTAP 111 is my neighbor, and whatever MAC I have learned through VTAP 1 through this Ethernet segment, I should also learn same on this, under this. Okay. So that's how it will update its MAC table. MAC sync will happen. And VTAP 2 will know that who is my neighbor, right? Peer. Okay. Any question? Okay. Similarly, this route also will be sent to this guy, P3 and 4, right? The same with RTA dash. But because here import route target import is different, right? Here this shares different route target. They will not import this route RTA dash. They will just ignore this, okay? Because they are not peer with P1, right? But when this guy is also sends their own local route target, right? Type 4 route, that will be installed on this guy when PE3 sends, and same vice versa. Okay. So now this will also, they will also know that, hey, we are peer of each other because we are sharing same route target value, right? So and then they will share the MAC address as well for that Ethernet segment. So this is how, so basically if you understand, right, whatever MAC learning or sharing MAC sync or ARP sync, all that information, right, which is done by MLAG or VXLAN agent. In this case, we are achieving same by using type 1 and type 4 route. Okay. So this is how we are achieving MAC sync, and we are understanding how, what are the peers. P2 will know, hey, which is my MLAG peer, right? So that's how this works. Any question for with this?
Hey Vishal, I just lost something there. The type 4,
Mhm.
how is this different from the type 1 in terms of the information we are sharing?
Okay, so if you notice, that's good point, right? So if you have noticed type 1 format, see, okay, so this is type 4 format. The one thing which is 1 minute, yeah. Okay, so this is type 1, right? If you see here, there is no route target of port channel. There is this extended community, but this route target is VLAN based route target, that 2 RDRT of under router BGP. Okay, 200. This is type 1 format. Okay,
Mhm.
so in route type 1, this route target you send, right? But that is not it is 200 route target, which you have configured under router BGP VLAN base. Okay.
Okay.
In type 1, you are not sending route target, which is configured under port channel 10, which is 0104 in this case. Okay. I'll show you in same thing in lab. Okay.
Yeah.
But if you see the type 4, right? This Ethernet segment import route target. So this is route target, which you have configured under port channel 10, 0104. That will be shared.
Okay.
Okay. So yeah, so this is the difference between this type 1 and 4. Both has different purpose. Okay. So I'll just show you the both the capture basically outputs for type 1 and 4. But before that, I also want to cover this designated forward election. Okay. So another purpose. So one is obviously, a dynamic discovery of multi-ohm beta peer, right? This guy will know what are my peers, right? So that they can populate MAC, share the MAC addresses. Another is designated forwarder election. What does that mean, right? Do you remember designated forwarder in case of multicast?
Yeah. Only one router sends pin joins.
Sorry, come again.
Only one router will send the pin joins to the
Okay,
multicast router.
okay, okay. What else? That is okay. That is DR and okay. But what else? Let's say what is another purpose? Let's say there is some multicast traffic or bump traffic comes. This is fine. Okay.
Mhm.
And these are VTAPs, right? So okay, see, this is one more VTAP, VTAP 4. Okay, this is
All
VTAP
the
1.1.1.1. Okay, this is VTAP 2.2.2.2. This is 3.3.3.3 and 4.4.4.4. This guy. Okay, now you want to send ARP requests for that particular VLAN or R in VLAN 10. You want to send this VTAP behind host and host behind this VTAP want to send out ARP requests, right? For another host, for this host, let's say. What will happen? It will send packet here, right? It will be flooded, right? This guy will has learned the flood list that has 1111 by using type 3 route 2222 and 3333, right? So flood list has all these three VTAP. It will create 3 copies of this ARP request, right? One is sent to 1111, another is to 2222, and third copy is 3333. Okay. Now what this guy will do, it will decapsulate the packet and ARP request will be sent on this guy. Also same here and here. So unnecessary, this host is receiving how many ARP requests for one ARP, right? 3, correct?
Mhm.
And same is the case for multicast also. So for multicast, let's say what happens, even in case of multicast, right? Multicast stream comes in, it might land on both this device and both device will forward that stream to this guy, right? Which is unnecessary. Unnecessary use of the bandwidth, and this guy has to process multiple packets, right? So that's why we have concept of designated forwarder, okay, which is also there in multicast. So what they will do is, out of these 3 VTAPs, right? So basically as we know, they exchange type 4 routes where they exchange all this information, right? So they know that, hey, there are 3 VTAPs in the network which belongs to or which are connected to common Ethernet segment, right? Ethernet segment A, right? So now they will decide based on this information update message, they will decide, hey, which one out of 3 of us, only one will be designated forwarder. Okay. So based on, there are criteria, I will not go but in depth about the criteria, but definitely there are notes here under this where criteria is mentioned. You can go through it, or there are other documents, I can forward it to you. Basically, out of these 3, one will become designated forwarder based on that criteria, right? And even though all 3 will receive the bump traffic or ARP request, only designated forwarder will send that request to the client host. Other 2 will just ignore that packet or drop that packet, right? They will not forward. Basically, they might definitely will forward to single home device or other port channels where they are designated forwarder, right? But for this port channel, the designated forwarder only will send that packet out, bump traffic. Okay. Is it clear? Any question?
So is designated forwarder like based on VLAN, or is it for all the VLANs?
Okay. Yeah. So that is okay. So designated forwarder will be based on port channel. For this port channel, there will be this designated forwarder, right? For another
Okay.
port channel, it can be some other designated forwarder.
Hmm. Okay.
Okay.
Vishal,
Yeah.
just a quick question. So, how will the other VTAPs in that segment know who is the designated? Like, is that also communicated? Like, one VTAP will say, "Okay, I am the designated forwarder
Yes.
for."
Yes. So, okay. So, see. So this is the criteria. So basically, see, that out of these 3 devices, basically, that, uh, this VTAP 1 will know that 2 and 3 are also sharing same Ethernet segment A, right?
Yeah, yeah.
Type 4 route. Okay. And everyone has information about other VTAP. So let's say this VTAP is 1111. He knows that other 2 VTAPs are 222 and 333. Okay. So based on that, they will decide on, right, that who will become the designated forwarder. Okay. So maybe the criteria might be of highest IP address. VTAP IP address will become designated forwarder. So based on that, they will decide who will become the designated forward. Okay, for this. And yeah, one more question, Akshit, about it will be per VLAN or port channel. I think I have to revisit it. Right now, I'm not able to recollect. I told port channel, but I think let me go through it. Okay, and I'll come back. Whether it's a port channel or VLAN.
Sure,
We had
sure.
a discussion around this in last session, but I right now I'm not able to confirm that.
No worries.
Yeah. So basically, this is the criteria. You can read through it based on which, but again, it will be based on whatever information in type 4 is shared, right? Based on that only, it will decide who will become the designated forward.
And that information, like, okay, I am the designated forwarder. It's not like communicated again. It's like
No.
okay.
So it is preset and based
Okay.
on, let's say they decide that whatever VTAP has highest IP address, that will be designated forwarder, right? Now, VTAP 1 knows that my peer is VTAP 2 and 3. So 222 and 333. And he itself is 111. So he'll know that, hey, designated forwarder will be 333. I am not the designated forwarder, right?
Okay.
Similarly, other 2 will also know that who is designated forward based on criteria.
Okay. All right. Got it.
Okay. That IP address is just example. It can be different criteria. Okay.
Yeah.
Okay.
But this DF is only for ESI port channels, right?
Yes, it is only for Ethernet segment, and even type 4 also will be shared only for that port channels, right?
Mhm. Okay. So what I'm wondering is if there is orphan port
Mhm.
on non-DF,
Correct.
and
So
if
for
it tries to, Mhm.
hmm, so
if it
this
tries
way,
to
right?
send a ARP request, yeah,
Mhm.
for this particular
Correct.
node only.
Yeah. So say let's say this is VTEP 4 and this host wants to communicate to B, right? Which is one single
Mm.
link, single home. It will send. Okay. So what it will do again? It will flood to all the VTEPs 111, 222, 333. This is 111, right?
Uh-huh.
Now for this port channel, right? Basically, this is orphan port, right? There is no port channel. So see, you know that the DF is only for this particular port channel, right? Port channel
Mhm.
10, this. Other than that, if this packet has to go out, so basically what you will do is say this is also VLAN 10, this is also VLAN 10, this port channel also, right? You receive the
Mhm.
packet here, here, and here, right? Now
Okay.
you have to flood this traffic to all the ports, right? What you will do is you will check that, hey, port channel 10, for port channel 10, I am not the DF. I am not the DF, designated forward. I'll not send packet here. Okay, I'll not send, right?
Okay.
But for this port ET5, or let's say here there is a port channel multiple links, right? Port channel 5.
Uh-huh.
I'm not the, basically there is no designated forwarder, there is no Ethernet segment common, right? No ESI. This is
Mhm.
standalone. So I will forward that packet here out,
Okay.
right? So basically now you know, right? For what are the
Ah.
Ethernet segment, right? Available, and who are the other VTAPs. You have all the information. Obviously, you know that on this port channel, you have not even configured Ethernet segment. So that's
Hmm.
how you know that is this is a orphan or single home. I have to forward that, right? But if there is a
Okay.
Ethernet segment on this port channel, then you will check, hey, I am DF or not. If I am not, I'll not forward the packet.
Okay. So if B has to communicate to this host on port channel 10 and it is connected on a non-DF, so the ARP
Uh,
request will go towards
No,
the
no. See,
spine.
this is all locally on this VTAP. This guy doesn't know, right? Who all are connected. This guy doesn't know.
Mhm.
See, uh, you received the ARP request, right? Now you have to
No,
decide.
if I receive the ARP request from orphan port for
Orphan port.
yeah,
Okay. Okay.
from
Yeah, from
orphan
here,
port,
right? From here you
yes,
receive ARP request. For which host? This guy?
this guy.
Okay. So this guy, right? So you received the
Mhm.
ARP request, right? Now you will check, hey, this is port channel 10, right? This guy will check port channel 10, right?
Uh-huh.
Okay, so first what you will do, you receive ARP request. Obviously, you flood
Mhm.
within your segment, right?
Mhm.
Within the switch, and you also send it to the other VTAPs 2 and 3, right?
Yes.
Flood. Okay. Now what you will check is, now before sending it here, you will check, hey, this belongs to port channel 10, right? Port channel 10, which
Uh-huh.
is common Ethernet segment. It's sharing common Ethernet segment A, right?
Mhm. Mhm.
And you also know that based on type 4 route that you have 2.2.2.2 other VTAPs, right? And another is
Yes.
333.
Yes.
And based on that type 4 route, you have decided who will be the DF out of this three. And you know that
Mhm.
333 is DF. So in that case, you will
Okay.
not send out this ARP request because you know 333 is going to send this ARP
Okay.
request out.
So, okay. So in this case also only DF will send out the ARP request.
Yes, yes.
Okay. Got it.
Okay. Okay. Any other question? Okay, so in that case, let me quickly show you the difference, right? Type 1 and type 4 route. So BGP EVPN route type. Okay, so let me first show you MAC address. Show MAC address table, right? So this, let's take a look at this, right? Say D5 D0. This is port channel locally connected, dual home, right? D5 D0. So now, as soon as you have configured show run interface, show run interface port channel 4. So you have configured this, right? That route target is this, local route target is 0044. Okay, and this is LACP system ID, and this is Ethernet segment identifier. Okay, and you have also configured VLAN 110. This is the route target. Okay, another route target, which is different from this route target port channel, and this is the other one, right? MACWOF route target. Now show BGP EVPN route type 1, right? So what are the different type? One is which one? Auto discovery. So auto discovery detail. So now what you are going to do is, okay, you will send out type 1 update, right? Type 1 update with Ethernet segment identifier, auto discovery type 1 update with Ethernet segment identifier ESI, right? Which we have configured here. This is 004. So this is 3 is different one, another VLAN port channel 3. For our port channel 4, it is this one. So port channel 4, Ethernet segment type 1 route, right? Ethernet segment identifier, route distinguisher RD, which you have configured under MACWOF, right? So this is the route distinguisher, right? So this is the route distinguisher, Ethernet segment identifier, route target, which is under MACWOF. So this is the MACWOF route target, tunnel type VXLAN and VNI information, right? VXLAN to VNI information. So this is type 1 route, okay, where this route target is this route target, MACWOF route target, okay, not the this route target. You are not sending this route target, okay. So this is type 1 information. You are sending, saying that, hey, I am part of this Ethernet segment, right? This VTAP 1 or VTAP PE11, I belong to this Ethernet segment. This is, I belong to this, okay, for this VLAN, okay. Okay, now let's check the type 4 route. Okay, so route type 4 is nothing but Ethernet segment type 4. Okay, so Ethernet segment detail. Now let's check same, right? So this is the one 003 yes 4, right? So this is my Ethernet segment type 4 route it has generated. This is the VTAP IP address who has generated that, right? If you remember the type 4, we send Ethernet segment identifier, IP address of the VTAP who has sent this, right? So this is that information. Route distinguisher, we send route distinguisher RD value, which is this, and we send this route target, right? This route target is nothing but not the VLAN based route target. It is this route target, import route target, right? So we are sending this route target, correct? So when this information is received by another VTAP peer, right? A multi-home peer, which is PE12, it will understand that, hey, because that the same is configured under his port channel also. So it will understand that, hey, this PE11 is my peer, right? For this Ethernet segment that we are sharing common Ethernet segment. And that's how it will understand that we are both peer with each other. Okay.
Vishal, shouldn't that be the ESI value by which they confirm that we are sharing the same segment?
One is Ethernet segment ESI value, but also it will check the route target, right? Just to understand that we are sharing the same Ethernet segment. Because if we remember this, right? here you will install this route on import route target, right? So here you have configured import route target as a dash, which is in your update message, right? This, and based on that only you will import this route and you will consider that, hey, this is my neighbor. We are sharing same Ethernet segment.
So it's both the values basically.
Yes, both the values. Yes. Okay.
So in that case, can we like have different ESI values for different VLANs with different route targets?
1 minute. Okay, so see, for port channel, okay, you mean to say what about different VLANs, right?
Yeah.
Okay, different VLAN. I think we have here two different VLANs, right? I'm just going to look at that. I think for both the VLANs that will remain same, right? Because it's a port channel.
So
So
ESI is per port channel.
yeah, yes, ESI is per port channel and route target import is also per port channel. So if this port channel has both the VLANs, right, then it will have same this values. So instead of here trunk allowed VLAN only 111, you have 111 and 112, then both will have same this values, right? ESI segment and route target. Okay.
But in that case, from type 1, the MAC URF should be different, or it should not be the same.
Okay, so in that case, the distinguisher will be, right, your VNI information, which you send in type 1, right? So in type 1, you also send VNI information, which will be distinguisher. Yes. So even your Ethernet segment will same, right? Route distinguisher, again, in VLAN based route distinguisher also will be different, right? So if you talk only about type 1 route, what are the information which will be different for both the VLAN and what will be this? So your ESI will be same, right? Because this port channel belongs to both the VLANs, right? But your RD is different. For VLAN 10, 100, it is different. VLAN 110, it is different, right? RD is different. Your VNI is different for both of them, right? And your route target in type 1 route, you send route target of MACWAF. So that also will be different. Okay. So only Ethernet segment identifier will be same. All other information in type 1 is different. Okay. Now let's talk about type 4. In type 4, you have same Ethernet segment identifier, same VTAP IP. So both this will be same for VLAN 100 or 110, but RD will be different, right? For 100 and 110, two different RDs in VLAN base. And also, okay, and this route target will be same because this is same as for port channel. Okay. So in type 4, only RD will be different for VLAN base, but other information will be same. Okay. But the information, the purpose of this type 4 is to understand, hey, who are my neighbors, right? And that you can get it from this. So that does not matter, right? VLANs under that port channel. So whatever information you are looking for with reference to type 4, that is either DF election or, who are my neighbor, that you are still able to get it from type 4. Okay. And whatever information you are looking for type 1, that is, mass withdrawal and remote VTAP load balancing aliasing. So for that, you have different VLAN distinguishers, right? RT values, which will distinguish and VNI, which will help you to learn that MAC address for that VLAN only. Okay, at the other side. And that's the reason, we have different fields for type 1 and type 4, so that problem does not come of that VLAN. Okay.
All right.
Okay. I think we can stop here, but yeah, before that, any question?
So Vishal,
Mhm.
for these two VTEPs that are neighbors, so yeah, like those two. So the MAC address I learned on the one on the left, maybe that one.
Mhm.
I will learn it on the other devices via the type, okay, type 2 versus bus together with the type 4, right?
Yes. So type 2, you know that, hey, this MAC is on this VTEP, right?
Yeah.
And type 4, you know that, hey, we both are sharing same common segment, so that we can combine both of this. And basically this MAC is also behind me. So
So
yeah,
even if they have not locally received any packet from the host or the end
yes,
device, they
yes,
would still, in the MAC address, they will automatically still learn the MAC addresses and point it towards the port channel.
yes, that's right. So in MLAG, the what we do MLAG maxing, right? That will be achieved by combination of type 2 and 4 in this.
Okay.
Okay. Okay. Any other questions? Okay. In that case, yeah, let's close close it for today. But yeah, again, please go through. Let me first stop this.